Hi, welcome to the final video on reactions of alkynes. The first reaction I'll go over today is going to be halogenation of alkynes. Now the mechanism for this is not very well understood, but how the synthesis will work. So I have the following alkyne. If I react with one equivalent of bromine, I will form an alkene with the following as the major product, but you will also get a minor product of the other stereoisomer here. So I'll just indicate this would be the major product. And right, this would work with Cl2, this would work with I2, both of them. If, however, I use excess of the halogen, so I have excess Br2, I will reduce all the way down to the alkane. As always, I just want to check my carbons, 2, 3, 4, and then the phenyl group, 1, 2, 3, 4, and then the phenyl group. So we're good. Up top, 1, 2, 3, 4, 1, 2, 3, 4. As I mentioned in the last video, my organic chem professor in college, if I didn't get the number of carbons correct on the final product, it was no partial credit, nothing. That was it. So make sure you're always counting your carbons to make sure you have the correct number at the end. Reaction number 2 for this video is going to be ozonolysis of alkynes. Now, if you remember, ozonolysis is used with alkenes as well. For alkynes, you're going to get slightly different products than you would get with the alkenes. So I'm going to put in a phenyl group again with this one. So we got phenyl. If I react with initially ozone and then water, my products are going to be carboxylic acids. So you get carboxylic acids when you undergo ozonolysis of alkynes. So I get 2 different carboxylic acids here with the 2 sides of the alkyne. Now the trick I use for these is I just put a little dotted line right through the triple bond. And I know that the left side of this dotted line, I'll get the phenyl with a double bonded oxygen and then an OH. And I know the right side, I'll get the OH followed by the carbonyl and then the ethyl substituent. So that's how I divide it to make it a little bit easier to see where I'm getting the carboxylic acids and what the carboxylic acids should look like. Now, if your alkyne has a terminal hydrogen on it, you won't get 2 carboxylic acids as the product. The first one will be a carboxylic acid, but the second product you get is just carbon dioxide. So if you have a terminal hydrogen in your alkyne and you undergo ozonolysis, one of the products will be carbon dioxide. Now the last alkyne reaction I'm going to review in this series of videos is the alkylation of terminal alkynes. And this will work only with either a methyl or a primary halide as your reactant. And you'll see when we go through the mechanism of this. So the first step, and this is a step that is very different from anything you would see with either an alkane or an alkene reaction in terms of the carbons and the hydrogens, is that we're actually going to make the alkyne into an ion, which you can't really make alkenes or alkanes into ions because it would just be too unstable for the carbon, right? The pKa of alkenes and alkanes is much higher. You know, an alkane, it could be 50 if it's a carbon with 3 hydrogen bonds at the end of it. So, right, if you have, you know, this carbon here, that might have a pKa of 50. And I went over that in the first video. But with the alkynes, because of the triple bond here, the bond length between the two carbons is smaller and the bond is stronger, meaning the bond length between this carbon and the hydrogen is longer, so that bond is easier to break. But also because that carbon-carbon bond is so strong, it can pull in the electrons that would be left on the carbon were this hydrogen to leave much closer, which makes it more stable. We still need to use a fairly strong base to be able to deprotonate here. So our reactant, we're going to have NH2 minus here. NH2 minus will come in. We've got an ion now plus NH3. This ion here is called an alkynide ion. So that's an alkynide ion. So now, via the SN2 mechanism, we'll react. I'm just going to put in here ethyl iodide. Kick off the iodide. And we will be left with our final product. And just count the carbons to make sure we have the right number. So 1, 2, 3, 4, 5, 6. We got 1, 2, 3, 4, 5, and 6 carbons. So I hope you found these videos on the reactions of alkynes helpful, and I'll be continuing to post more content on organic chemistry.